Welcome back, everyone. In this lecture series, we're going to be discussing Matplotlib styling. In part 1, this lecture video, we'll be discussing how to add a legend to your visualization, and in part 2, we'll actually talk about editing styles such as colors and line widths. Matplotlib offers very robust styling functions that allow us to edit all kinds of properties in our actual graph or axes. And that could be things like editing the colors, editing the legends, editing line widths, adding in markers, editing the tickers, the thickness of the axes objects itself, and much, much more. However, you should note, due to the wide amount of possible variations, we're not going to be able to show you every single possible variation here. Instead, for a lot of it, especially in part 2, we may be copying and pasting from the lecture notebook to save some typing time in the video, such as saving time as far as showing you every single marker that's available, that sort of thing. The main styling that we're going to be discussing in this series of lecture videos is first, in part 1, we'll just focus on adding in a legend and labels to your visualization. And then in part 2, we'll talk about things like visual styling, editing your colors, editing lines like the different colors, widths, and styles, and then editing and adding in markers like colors, size, style, edges, and so on. Okay, so let's go ahead and jump to a Jupyter Notebook and begin with adding in legends. Okay, here I am at the notebook. I've imported NumPy as NP, and I have matplotlib.pyplot as PLT. Let's go back to using a figure object. We'll say fig is equal to plt.figure. We've created this figure object, so let's add a set of axes to it. And we're just going to add in one set of axes. We'll say fig.add_axes, and let's make it just take in the entire canvas. So 0, 0, bottom left corner, 1, 1 for the width and the height. And then off this axis, or axes, I'm going to plot, and let's go ahead and just plot in, let's create some data first actually. Let's say x is equal to np linearly spaced from 0 to 11. Let's go ahead and have 10 points. And then what we're going to do is actually, I'm just going to use x by itself. So I'll say plot x versus x. So if you run that, you see this linear plot x versus x here. And then what you could do is plot again on the exact same axes. So I could say x.plot, and then I could say something like x and then x to the power of 2. So if you run that, now we have these two lines. However, you'll notice that technically, if I were to just see this plot by itself, I wouldn't actually know what each line represents. I could see that one looks linear and one looks exponential, but it'd be hard for me to backtrack and fully understand that one is x versus x and one is x versus x squared. So what I could do is add in a legend that will tell me what each color represents. So to do this, what we need to do is two steps. One, with each plot call, I need to add in a label. And this label is simply a string that I want the legend to associate with this particular plotted line, x versus x. So the string could be something like x versus x. And then the label for this one, as a parameter, is just a string, and you can type in here whatever you want to be associated with it. So this one will be x versus, let's say, x to the power of 2. And then at the end of all this, on the axes object, you call ax.legend. So you run that, and now we can see here I have x versus x is blue, and then x versus x squared is orange. Okay, so something to note is that technically speaking, if we had a bunch of lines here, the legend could overlap one of these lines in theory. So you can actually tell Matplotlib where to place the legend, and there is this dot, or if we expand on this, there's an LOC argument. So if you scroll down here, you'll notice eventually, after it tells you how to actually use it, and you keep scrolling down, it tells you there is an LOC argument right here, which is a string or a pair of floats, essentially telling you where to actually locate the legend. And so you can actually add in a string telling it upper left or upper right, or you can add in a number associated with it. So 0 right here is automatic best location. It tries to figure it out on its own. You could also say upper right, upper left, lower left, and so on. So you can actually pass in to the LOC argument where you want the legend to be located. So for example, I could say LOC is equal to lower left, run that, and now the legend here is in the lower left. Or what I could do is just pass in the numeric codes that are associated with that. So I could say maybe lower right corner, which is just the number 4. And now you see it here in the lower right corner. By default, it uses location 0, which essentially lets Matplotlib try to decide where it's going to cover the least amount of information. But let's imagine we wanted to actually manually set the location. We can do that quite easily. All we need to do is pass in a tuple, which corresponds with the exact same two parameters here for the bottom left-hand corner. So what I could say is start at 1.1, essentially outside of that figure canvas, and then have it be halfway up off the x-axis. So if you run that, now you actually get to see your legend outside of the plot. And so what this is doing, again, it's where the bottom left corner is going for this particular legend. So if we said something like 0.5 by 0.5, you should see it right in the middle of the plot for that lower left-hand corner. So typically, you're going to see this first x outside of 1. So it actually shows up completely outside your plot. If you wanted to, we could also say something like negative 0.1 if we wanted to see it over here. Again, recall, it's issuing it to the bottom left-hand corner, so you may actually need to do more than negative 0.1, maybe something like negative 0.5 to see it over here on the left-hand side. It's up to you to play to this location to put the legend exactly where you see fit. Okay, so again, the main things to note here for adding in a legend are after you've added in a set of axes and you're plotting multiple times on it, it's probably a good idea to have some labels there so someone visualizing your plot or viewing it can actually understand what colored line goes with what information. So here you would just add in a label on each plot call, and then at the very end called ax.legend, and it will automatically connect this string label to the correct colored line. And it's up to you to locate it wherever you want, or just let Matplotlib choose by saying LOC is equal to 0. All right, thanks. And coming up next, we're going to be talking about setting colors, line widths, and line types. I'll see you there.